We are going to be using in this lesson two methods, algebraic methods, to solve systems of equations. We're going to be solving linear quadratic systems of equations, just like we did yesterday, and quadratic systems of equations, just like we did yesterday, except we're not going to use graphs. The two methods are called elimination and substitution. So to begin with, these are things you learned in Math 10. When you have two equations, which is a system of equations, and you're going to solve it using the method of elimination, your goal is to eliminate one of the variables from one of the equations by adding or subtracting multiples of the equations together. There's a small typo here, but if you're reading it and you don't notice that that typo is there, you might kind of stumble at what it means. It should be multiples. I'll give you a very, very quick example here from grade 10, and there's no need to write it down. 3x plus y equals 21, and x minus y equals negative 1. There's a system of equations, and that happens to be a linear system. Now think for a second here about solving this graphically. It wouldn't be difficult. You'd rearrange each equation for y, you'd put it into your calculator, you'd find the point of intersection. But notice that if I add the equations together, 3x plus x is 4x, y plus negative y is nothing. I've eliminated the y from the equations. And I end up with 4x equals 20. 21 plus negative 1. Well, I divide both sides by 4 and I get x equals 5. Once I know what x is, I can put x equals 5 into one of the equations and solve for y. Does that ring a bell? Hopefully it does. It's a very quick, simple method. Well, that's what the method of elimination is, except that here we're not going to be dealing with linear and linear. We're going to be dealing with quadratic and linear, or quadratic and quadratic. The other method is called substitution. And substitution also eliminates a variable. It also gets rid of a variable, but it doesn't do so by adding or subtracting the equations together. It does so by substituting the result of one equation into another. I'll give you another example here. So if I gave you that, and this is a Math 10 question that I've written down, rather than use elimination, what you can do is take this second equation and rearrange it for y, for example. So according to the second equation, y is negative 10x plus 56. Thank you for the frowns, which told me I wrote something down wrong. So the second equation is equivalent to saying y equals negative 10x plus 56. So what we can do is put this in there, because y is negative 10x plus 56. And that means the top equation becomes 3x plus 2 times negative 10x plus 56 is equal to 27. And I don't know that I really want to solve this. It's not that big of a deal, but the point is now you have an equation that has x in it and no y. Let's solve it. I would expand this out. How's my math there? 2 times 56 is 112, I think. Is get your calculators out and figure out what we're going to have here. You're going to have to take 27 and add 112. You're also going to have to take 3x minus 20x to get negative 17x. And then you'll have to do a bit of division there. This should be plus 112, shouldn't it? Been away from it for too long. Remember what I've told you. Do every step twice, right? Double check. So you're going to have to subtract 112 and get, I believe, negative 84, but I need some help in many ways. Is it not? Negative 85? Negative 85. And then here I get negative 17x, I believe. 85 divided by 17. 5. So x is 5. Once you know what x is, then of course, you know x equals 5. Feel free to throw that x equals 5 in wherever you like and solve for y. I want you to notice something, that with elimination, you solve for one of the variables by eliminating the other, but then to get the second variable, you put that back into an equation. And you do the same thing with substitution. You substitute in to get one of the variables, and then you put it back into another equation. All right. Solve the following system of equations using elimination. So we have to eliminate things. Now, I don't know if you noticed, but when I wrote these two equations, which I'm just going to highlight here for you, everything was lined up. The x's were on top of the x's, the y's were on top of the y's, the numbers were on top of the numbers, the equals was on top of the equals. I'm going to suggest to you that that is always your first step, is to rewrite the system of equations so that things are consistent. So, for example, I'm going to rewrite this as x squared minus x minus y equals 6, and the other one as 2x minus y equals 2. So things are nicely lined up. Does that make sense? You guys are with me on that? Okay. Had this equation here said 2x minus y minus 2 equals 0, which is the same equation, I would still write it this way. I would move that 2 over so it's consistent between the two equations. Now, I'm going to pick your brain here. How many of you remember last year that in elimination sometimes you subtract the equations? Okay, this is good. How many of you remember from last year that you never subtract them, you just arrange it so that when you add them, something goes away? So this is my thinking. Don't write this next part down. You're going to have to think about this. See, what a Math 10 teacher might do is say that since this is negative y in the first equation and this is negative y in the second equation, you're not writing this down, your Math 10 teacher might say, let's subtract the equations. And then they would say x squared, well, minus no x squared is x squared. Negative x minus 2x is negative 3x. Negative y minus negative y is nothing. 6 minus 2 is 4. Does that make sense? Nothing wrong with that. But do you agree adding is easier than subtracting? Okay, so in my mind, this is the best approach. You can take this advice or leave it. always add the equations to eliminate a variable. And that means if you're going to eliminate the variable, say the y, you have to have the opposite number of y's in each equation, which means I'm going to multiply this top equation, or sorry, this bottom equation by -1. I'm going to rewrite it by multiplying everything by -1. So it's going to become -2x. I'll put this in a different color just to... I'm taking this equation and I'm multiplying it by -1. And getting -2x plus y equals -2. So what I've done is I've arranged it so that the bottom equation now is -y and the top equation has positive y, or the other way around. Okay? The bottom equation, I guess, has positive y and the other equation has -y. So I'm going to rewrite this other equation as x squared minus x minus y equals 6. I hope most of you understand I'm going to get the same thing as what I got when I told you don't write it down. Subtracting is the same as adding the negative. So anyway, now I get x squared minus 3x equals 4. We've eliminated the y's. This is an equation that everybody should know how to solve. It's quadratic. We can zero the equation. Factor it. Two numbers that multiply to give -4 and add to give -3 would be -4 and +1, which means we have two solutions. I don't know what that's there for. We have two solutions, x equals 4 and x equals -1. Are we done? No, we have to find the y coordinate, right? We're solving a system. So how do we find the y coordinate? Well, we can use any of these equations. By the way, when I say you can use any of the equations, you can use either of the two equations you started off with. You can use this equation that you got when you multiplied one of them by -1. It doesn't matter which equation you use. I'm going to use the second equation. I'm going to use this. So 2x minus y equals 2, which means 2x minus 4 equals, which means 2 times 4 minus y equals 2. So I'm putting x equals 4 into the equation. And then I solve for y. What do I get? 8 minus y equals 2, which means y is 8 minus 2, y is 6. So one of our solutions is x equals 4, y equals 6. Do that with the other one. We have 2x minus y equals 2, and x was -1. So I get -2 minus y equals 2. Move the y over, subtract the 2. Y equals -4 is what I get. We good? I just sense a lull in the room. Too easy? No questions then. Okay. So the other solution is x equals -1, y equals -4. What's the best way we can verify this? Well, let's just, for kicks, let's put it in our graphing calculator and see what happens. Let's just confirm that these are the solutions. I think that's the most straightforward way to verify it. The only, it's not really a problem. The only thing is you have to rearrange each of these for y first. But to rearrange each of those equations for y, we can move the y that's negative to the other side where it becomes positive, and then move everything else out of the way. So the first equation is y equals x squared minus x minus 6. The second equation is y equals 2x minus 2. Are we in agreement on the arranging of the equations to get y equals there? Again, I sense that some of you are tuning out, so just want to make sure you're thinking about this. Zoom 6, that's our starting point. Definitely has two intersection points. The one on the left is at -1, -4. Jackpot. That's what we had. The one on the right (4,6). Was that what we had? 4,6? Okay. I mean, you're not going to check these all the time. I'm just pointing out to you that it worked. Let's try this one. Ooh. So, yeah. Can you say that again, please?
So for this one, if they have two answers, there's no like extraneous answer, right?
No. The question is, sometimes when we get two answers, you throw one out because it's not valid. There aren't any extraneous answers here. The only time you would get an extraneous answer, one that you would throw out, would be if it were maybe a word problem and the question said that the two numbers have to be positive, each positive, then you would throw out the one that has negative. Yeah. Okay, example B has the second equation that's very awkward. And what I will tell you is you never want to work with fractions unless you have to. So remember that you can manipulate these equations any way you like. I'm going to write this first equation as x squared minus y equals -1. And I'm going to take the second equation and I'm going to multiply by 2. Why am I multiplying it by 2? Luke? Get rid of the fractions, right? I don't want fractions. If I can get rid of them, I can. And I should. So 2 times the x is 2x. 2 times -3/2 times y is -3y. And 2 times -11/2 is -11. That's, in my mind, everybody, just the preliminary. Get rid of the fractions. Now, let's rewrite them again so we space things out so things are lined up. Right now, I've got x squared lined up with x. Well, that's no good. So there's a number of ways to do this. I'm going to write x squared minus y equals -1. And here I can write 2x minus 3y equals -11. So I made a column for x's and a column for x squareds. I want to back up for a second. Is it clear with this first system of equations? And I will highlight the system right here. I hope it's clear that if you're going to eliminate a variable, it has to be y and not x. You can't eliminate the x and the x squared. It will never work. You're always eliminating the variable that is never quadratic. So over here, that means we need to eliminate the y's. Who can tell me what the best line of attack is here, you think, to get rid of the y's. Remember, I have to, go ahead. Okay, if I multiply the top equation by 3, I'm going to get, so this is, we're kind of all over the place. You need to be organized. I'm going to multiply this equation by 3. And the top equation is going to become 3x squared minus 3y equals negative 3. So these are the two equations I'm looking at right now. Since I've multiplied this equation by 3, I'm no longer worried about that equation. I'm worried about the equation I get. What would you do now? So you're going to multiply the other one by negative 1. Okay? And if I multiply the other one by negative 1, this is the negative thing is easy. I don't need to rewrite it. I can just do this. Right? And then what would you do to the two equations? Add them, and the y's would go away. Is there, and there's nothing wrong with that, and everybody thinks differently. Is there something I could have done to eliminate one of those steps? Alexis? Multiply by negative 3. And I'm not saying what you did is wrong. Whatever works. But what I probably would have done is multiplied by negative 3. And what's going to end up happening here, and I think you see this, is anytime you have the y's that you're trying to get rid of that are both negative or both positive, you're going to have to multiply one of the equations by a negative somewhere along the way to add them. So now I can add these equations, and I will just highlight the equations that we are adding. Again, there's a lot to follow here. I'm going to take this equation and add this equation. And what do I get? Negative 3x squared. There's a negative there. Plus 2x equals negative 8. I would say that the advice I would give you here that's the most valuable is you need to be organized. Because you're going to be dancing around from line to line, and we started off with these two equations, and now we have this equation and this equation that we're working with. So you have to really keep track of things. So how do we solve this? We look at it, we say it's quadratic. I need to zero the equation. I've learned from a previous unit that I don't like negative x squared, so I move the x squareds to the right. Everything else follows. I've learned in a previous unit that there's a trick I can do to find out if this is factorable or not. And it's the b squared minus 4ac thing. I believe when you do b squared minus 4ac, but I'll give you a second to do it, that you get 100. I'm starting to see some nods. 100 is factorable, 100 is a perfect square. I'm guessing 2 and 4. 4, 2, 4, 2. It's not a factoring lesson. You need to know how to get it to that factored point, which means x equals 2. And x equals negative 4 over 3. Now, it's been a while. How did I get, can somebody volunteer up how I get negative 4 over 3 for that factor? Isaac? I kind of get what you're saying, but I think there's a cleaner, I think there's a cleaner approach that's easier to understand for most people. Seamus. Well, there's something, a bigger picture here that both of you are not saying. And I know that in your head you're getting it. Go ahead. Right. You're saying that that factor equals 0, and then you're solving that. You're moving the 4 to the other side, and you're dividing by the 3. So you get negative 4 equals 3x. You divide by 3, you get negative 4/3. Anyway, that's x. Each of these now has a y. Right? 2 answers. So you have to find y. You have to go on a little mathematical field trip or journey and get an equation that you can use to find y. Let's see. Oh, I like the top equation to find y. If x squared minus y equals negative 1, then y equals x squared plus 1. Rearranged. I move the y over, I move the 1 over. So all I have to do is square x and add 1. You can use your calculator here. 2 squared plus 1 will give you 5. Then we have to take negative 4/3 squared and add 1. And I believe we're going to get 25/9. And I'm seeing a couple of nods. So any questions with A or B? All right, we just have one more example. It's number 2. We're going to be using substitution. Remember, with substitution, you take one of the equations and you rearrange for a variable to substitute it into the other. So let me ask you a question. Think about this. Do you think I should rearrange this equation for y? Does that make sense to you? Why would I do that? I'm going to end up having x squared and x, and I'm going to divide by 4, so I'm going to have numbers like 37 over 4. It's very difficult to rearrange that equation for y. It's going to be much easier to rearrange this equation for y. Very easy, in fact. All I have to do is move the 4x squared over. Actually, I'm moving the y over. Moving the y to the right, and I will have negative 4x squared minus 2x plus 5. So with substitution, now what I do is I take this thing, which is y, and I substitute it into the second equation. By the way, if you substitute it into the equation that you used to get it, you're just going to end up with a statement like 0 equals 0. It won't go anywhere. So I'm going to have 3x squared minus 4 times y, which is negative 4x squared minus 2x plus 5. Then minus 46x. Then minus 37. And it's equal to 0. Let's double check that line. Y is equal to negative 4x squared minus 2x plus 5 is correct. I put it in for y in the second equation. It looks okay. So now we have to simplify this. We're going to multiply that 4 through. Double check it. I think it looks okay. Give you guys a second to double check it. Okay. Notice that it's quadratic, so we can simplify this as 19x squared minus, I might need some help here, is it 38x? It is, minus 38x. This is looking good because 38 is divisible by 19, which means if the number, the constant, is divisible by 19, then I can factor the 19 out. It is 57, negative 57. I believe, but you better help me out here, that 57 is divisible by 19 3 times. Okay. This makes my life a lot easier because then I can factor out that greatest common factor and not have to deal with big numbers. Oh yeah, for sure. So let's see, x minus 3, x plus 1 equals 0. Two numbers that multiply to give negative 3 and add to give negative 2, which means x equals 3 and x equals negative 1. And, well, now I go find an equation I can use with x to find y. It's entirely up to you. What's going on here? There it is. I would probably use this equation right here. This is kind of the nice thing about substitution, because at some point with substitution, you've written, for example, y equals, and then you can use it to find y once you find x. So if y equals negative 4x squared minus 2x plus 5, help me out, is that correct? It is. Then all I have to do is pop 3 into that equation. You know, if it were a written response question, you would be showing all of your work, but at this point today, I just want you to calculate what y is by putting x equals 3 in. No? I better double check that then. Negative 37. Okay. And putting negative 1 in. Negative 1 squared is 1 times negative 4 is negative 4. Negative 2 times negative 1 is 2, so negative 4 plus 2 is negative 2 plus 5. I'm getting 3. So are you. Excellent. Those are our two solutions. And again, we don't have to worry about extraneous roots. Any questions with 2b, or 2a rather? All right, let's try 2b. This is the final one. Oh, this one's a lot easier, I think. We're asked to use substitution, so I would rearrange the first equation for y. Y is 5x minus 10. We're going to put that into the second equation wherever there's a y. So the second equation is x squared plus x minus 2y. But y is 5x minus 10. This is equal to 0. Simplify by multiplying this negative 2 into the binomial. Double check. Looks okay. It's quadratic. So we make sure that we zero the equation. One x minus 10x is negative 9x. Oh, this is child's play. two numbers that multiply to give 20 and add to give -9 are -4 and 5, which means one of the solutions for x is 4, one of the solutions for x is 5. Y was 5x minus 10. So use that to calculate y. We put 4 into 5x minus 10 and we get 10 for y, yes. We put 5 in and get 15 for y. So those are our two solutions. Just curious. So any questions with this one? Of elimination and substitution, how many of you have a preference? How many of you prefer elimination? How many of you prefer substitution? So that's always the way it goes. It's kind of about 50-50. I like substitution, even though it seems like it's more work sometimes. It's not as confusing. With the elimination, it's very cluttered. You're bouncing around from equation to equation. If you can learn with elimination to eliminate, no pun intended, if you can learn to minimize all of the steps, it's very clean and quick. And some people will even prefer with elimination, they will use, say, elimination to find one of the variables, and then they will try to use elimination to find the other in grade 10. That won't work here because of the quadratics. You cannot eliminate the quadratic variable. So at this level, I kind of lean towards substitution. Anyway, that's it. Today is a day of testing and building your algebra skills back up.